So our next talk is The Marvelous Mystery of Micromounts by Cailin Meyer from the Smithsonian.
Good morning, everyone. Can you hear me? Excellent. All right, so on the screen here is a photo of a uranium micromount specimen that resides in our education department, and it represents sort of a 3-year professional and personal journey for me. So back in 2016, I had the opportunity to work with our education department's micromount collection. And when I was first told of this project, my initial reaction was, what on earth is a micromount? Full disclaimer, I am a comparative anatomist and not a geologist. So according to the Baltimore Mineral Society, a micromount is described as a mineral specimen that requires magnification to be fully appreciated. It is permanently mounted in a box for protection, and it is labeled with the mineral's name and its collection location. The specimens are usually very small, and they almost act as a representative sample of larger deposits. And each specimen in the education department's collection resides in a box like the one pictured here, and they're no larger than an inch square. So what scientific purpose do micromounts fulfill is another thing that I was asking. Well, I now know that many geology researchers put micromounts like fully in the realm of hobbyist and personal collecting. But I've also met geologists who have said that they can be used for research, and especially for destructive sampling techniques, where a micromount from a known larger specimen can be sacrificed instead of harming the original. I've also met one geologist who says that they use their micromount collections for synchrotron measurement studies. In a nutshell, and as far as I can understand, a synchrotron measurement is used to study the coordination structure between atoms and minerals and molecules. But again, a comparative anatomist, not a geologist, so don't quote me on that. And finally, I've had a few geologists speculate that if the micromount represents type mineral specimens, they could then be used for comparison to field samples, and that their small size would be a benefit because you could actually and easily take some into the field with you. And I would personally argue that because they are so small and someone has gone through the trouble to make sure they don't get lost by mounting it, you can assume that the sample is precious in some manner. So micromounts have apparently a range of applications and uses, but I suspect that their most powerful one lies in their educational worth. A micromount is essentially a smaller representation of a larger whole. Their size and permanent housing means that they make excellent teaching aids for students of any size and experience. They can serve as an introduction to minerals and geology to elementary students, for instance. Their small size means they can easily be stored and used in any classroom setting, from informal education in a museum to being part of a school's learning lesson. Undergraduates could use them as study aids and representative samples during field work and coursework. And a single cabinet drawer can house literally over 600 of these micromounts. That's 600 mineral samples representing 600 different localities, which would allow any student to compare and contrast the minerals that make up our planet. So there's a lot of power there. So this particular sample is part of our education department's collection, and at the time of the collection's donation, it did not have the accompanying collection did not have an accompanying inventory with it. So I was brought in to catalog that collection, and again, I'm an anatomist by trade, and I came in with basically a high school level's understanding of earth science and geology, so there was an extremely steep learning curve for me. I became a temporary expert in the classification of minerals, their various crystal systems, and their chemical compositions. I should also note that I have completely forgotten the vast majority of that information at this point, but it was nonetheless, it was a really extremely fun experience learning about an entirely different field of study. And I have to give a shout out to Catherine Roberts for helping me along with that journey, because she started the project before I came along. Because it was an uncatalogued and uninventory collection, the education department didn't really know what was in there. And as an anatomist, I didn't know what to expect, but you can probably imagine the shock of adrenaline I experienced when I picked up this particular box and read the word uranium. And what followed that moment has been a 3-year journey in reviewing and studying the museum safety protocols, starting with this. So the education department now all has personal dosimeters and a Geiger counter, and that's the story.